All right, guys. Welcome to today's session. Today, me along with Jatin are going to take our session. So, let's get started. Okay, so I hope you guys can see my screen. Welcome to our second session of our data science journey. The last week we covered the basics of working with data, like loading it, understanding, describing data, then filling null values and all. So this week we're going to dive into something that's very crucial. It's data visualization and exploratory um, data analysis, or EDA. So EDA is very important, and it is in fact the most important step in data science workflows because, simply put, if you don't understand your data, you cannot model it well. So we'll talk about why EDA matters, what tools we use, what kinds of plots we can use to visualize data, and how to build a strong intuition about data before jumping into machine learning. All right. So, what is our motivation? So, raw data is often very messy, incomplete, or unclear, as we saw in the last session. Visualization helps to see patterns, spot errors, and even explains the data well. Um, when you think of raw data, it's a big ball of puzzles, missing pieces, weird numbers, strange formats. So if we start building a model on that mess, it is almost guaranteed to fail. EDA lets us explore, clean, find patterns before we even worry about training the model, what algorithms to use, etc. Another way to look at it is data visualization. Another way to look at data visualization is how you make data talk. Visualizing and summarizing the data helps you answer key questions like, are there any mistakes? Are there what patterns are there in the data? Are there any missing values? Are there outliers? So EDA is discovering insights, creating early hypothesis, and it helps you build a solid foundation. And if you skip it, it will create major problems in your models. So it does support better decision making with evidence rather than assumptions. So what is EDA? EDA stands for exploratory data analysis. It's a process of summarizing your data visually and statistically. You're basically exploring your data set from all possible angles. um, the core goal, as we can see over here, is to talk with the data, is to understand what is going on over there. There are various steps involved. So the key goals of EDA are to understand the distribution of the features. We can use descriptive statistics like the ones we used in our previous session, like mean, median, standard deviation, the count of each number of each features. We can use various plots to visualize data. So in this session, we're going to talk about pie charts, bar plots, and histograms. And we can also spot outliers. So outliers are basically those which do not fall under your model or which are different compared to it, and anomalies which are um, is basically different than the rest of your data. It helps us look at relationships between variables, and you can even check if the data actually aligns with what your goal is. I mean, so when you're doing this and it is completely different from what you want, so you can drop the data set and search for a better one. So in the end, you gain a deeper understanding of how your data behaves. What are we trying to find over here? So we can see the shape and spread of the data, the how the data looks overall, what variables might be important, how are different features related to each other, what patterns can we see, and we can draw inferences so that we can build early hypotheses for modeling. Or are there any weird or extreme values? So, in other words, EDA is the first step for your model. Right. And what can we use? So we can use so we saw pandas last time. We can use a matplotlib or seaborn, which are both visualization tools, which will help you build plots for various data. Plotly is another module. NumPy for calculations, and scikit-learn for advanced statistics. Now we can to actually make sense of the data, we have to use descriptive statistics like mean, median, standard deviation. It tells us about the center and the spread of the data. Then we can use visual plots to get the immediate picture. And finally we apply um, functions we learned in pandas to gain a better understanding. Okay. So the commonly used charts over here, mostly. So we're going to use histograms. It shows us the frequency, and it helps us to see if the data is skewed or normal. Skewed basically means it is more in one side of the graph or the other. It is easy to understand the spread and the concentration of data. And box plot is another important graph. It shows the distribution of data through quartiles, which are basically percentiles. It highlights the median, the interquartile range, the outliers, and all. And we can see the box. The starting the of the box represents the minimum. The Q1 is the first quartile, or the shows the 25% of the 25 percentile of data. Then Q3 shows 75, and so on. And with block spots, we can also spot outliers, which are represented by these circles at the end of the graph. It is great for spotting skews and extreme values. And more commonly used charts are scatter plot. It puts the relationship between two numerical values. It helps to identify correlations, and it helps us clusters or unusual patterns. And we are going to use this in regression analysis or clustering. And pie chart is another simpler chart. It shows the proportion of categories on a whole. As a whole, you can use it for simple categorical breakdowns, but yeah, it can be misleading if there are too many slices or if the data is divided into many parts. So what are we going to do when we say we're going to do exploratory data analysis? So we're going to load our data set. We're going to understand what we're doing. We're going to check for missing values. We have covered all this in the previous session. And then from this session on, we're going to see how to visualize distributions and how we can look for relationships, how we spot outliers. So you can take down your observations now. So let's see it in action. So Jatin is going to give us the demo.
Uh, am I audible?
Yeah, Jatin, you're audible.
Okay. So let me present. Yeah. So is the tab visible? Okay. So before showing this, wait a minute. Yeah. So before explaining anything to you, I just want to just tell you like how to analyze data set. So in this we are going to use Titanic data set just as the previous lecture. So As you can see in this data set, we are having a few columns like passenger. It is like SR number, like passenger 1, 2, up to like whatever passengers are there. SR number you can understand. This is like the survived column, like which all passengers survived. 0 means no, 1 means yes. Passenger class is like in which class that particular passenger was traveling. So it can be like 3, 1, 2, or anything. So it's like you are having in train now, third AC, second AC, first AC. Same way in the ship, there might also be like passenger classes 1, 2, 3. These are the names of all the passengers. These are their genders, ages, and SIB-SP. SIB-SP stands for sibling and spouse. So with any particular passenger, how many sibling and how many spouse are traveling. For example, with the first passenger, there is either one sibling or one spouse. With this passenger, there can be like either three siblings, one spouse, two siblings, or any other possibility. This parch column, it tells you like how many parents and how many children are traveling with that particular person. So for example, these all, there are no parents or no children. For this particular person, either one parent or one children can be traveling with it. For this, either one children or two parents or any other possibility, like how many parents and how many children are traveling. This is their ticket number or something. This is the fare which they paid for traveling in ship, like $30, 121, etc. This is their cabin number, like which cabin was allotted to which person. So as you can see, it is having a lot of missing values. This is the embarked column. Embarked means at which station particularly they boarded the ship. Just like we are having stations on train, same way they are having stations for ship across cities or anything. So S, C, Q, there are various values which we will explore now. So I think you all have understood data set for now. Let's move on to visualization. Before visualization, I just want to brush up all the concepts which Shashank explained to you in the last lecture, because I know most of you didn't attend it. So at first, we are importing all the necessary libraries like pandas, numpy. This is regular expression, matplotlib and seaborn, which Shashank told you for graphs and all. This way we load dataset pd.read csv. Using pandas, we load the dataset. If it's CSV, we use CSV here. If it's Excel, we use Excel here, or any other abbreviation for any other extension. So df.head, it gives like a brief overview or like top 5 columns for your dataset. So you can see here, like it will tell you what all dataset, top 5 rows, it will give you columns. Data frame info, df.info, it actually summarizes the whole dataset for you. So here, like you can see, it summarized the dataset. For example, see this passenger ID, this is a column. It is like how many non-null values are there and what is the count. It will show that, and which data type that particular column is. It's int. Same for survived, names, age, gender. It's like there is no null value in gender. For age, you can see 714 non-null values are there, which means remaining are null values, and it's float. Same like for ticket, there is also no null value. But for cabin, you can see there are many null values, like only 204 non-null values are there. Embarked is like a few null values are there for embarked. Also, you can just count how many null values particular column is having. df.isNull.sum. IsNull is like it will take all the null values from particular column. .sum will just sum them all. df.describe, include all. It will just describe all the columns like this way. You can see it. Hello. Did anybody spoke something?
No, I don't think so. Carry on.
Okay. So yeah, see, these are missing values. Let's summarize them all. For describe, this is what it shows. So there are various ways of handling missing values, which Shashank already told you, using mean, median, mode. So for age, you can use either mean or a median, whatever. It don't really matters because it's like not too much of null values are there. So we what we will do is like we will use median here. So we will what we will do, df of age equal to df of age dot fill na. Fill na is a function that like fills all the null values in that particular column with median age. Median age we already concluded as df of age dot median. So all the non-null values will be filled with median. All the null values will be filled with median in the age column. For embarked, it's like only two, three null values are there. So what we will do, like we will just take the mode, like which at whatever station most people boarded, we will just take that particular station and fill it with like fill that station in place of null values. Hash cabin. So like cabin is like there are so many null values in the cabin. So it's not practically possible to just include that column and move on for that what you say visualization and all. So what we will do, we will create a new column if that particular person is having a cabin or he is not having a cabin. So if that particular cabin is not having a null value, then we will just keep it as 1, else we will keep it as 0. We will create a new column hash cabin. So yeah, now we will drop the cabin column, df.drop, final missing value check, df.isnull.sum. As you can see, all the columns missing values are 0. Hash cabin, you can see it's newly created column, 0 missing values. So now I told you like parch and sibsp, those are like sibling and spouse and parent and children. So we will create another new column which is family size, like what family size a particular person is having. So it will be like sum of like how many sibling and spouse are traveling with him, how many parents, children's, and also it will be included including with one like plus one because that person itself comes into family. So yeah, every person will have a new column. So if person one is there, the new column family size will tell the family size of that particular person. Also, there will be a column of is alone. It will be like 0 or 1. If the family size is 1, we will keep it as like 1. If family size is more than it or anything, we will just keep it as 0. So as you can see, dot h type of int, it's like sets the data type. It can be int, float, anything. But as you can see, we are having only two values, 0 and 1. So we are setting it as int. Also, in name, as you can see, let me show you again. In name here, like broad Mr. Owen Harris. Also, this Cummings, Mrs. John Bradley. So here titles are Mr., Mrs., etc., etc. Also, there can be many other titles which we will just extract it here. So we are creating a get title function using regular expression. We are just extracting the title Mr. or Miss. Yeah. So now we are creating a new column of title again, which will be like from name, like df of name dot apply. So it will be like in the name column we are applying a function get title dot apply applies the function in the name column that will be like set to title column. So if a particular person like person one like this future Mrs. Jax. So for her title column will come here and then Mr. or Mrs. whatever will be there it will come in the title column for that particular person. Title count, like all the unique values of title you can count it separately. Dot value using the value counts. We will be like you can see it here Mr. Miss Mrs. Master. They are the common titles, but there are others like Dr. Rep, Colonel, military, etc. etc. So we will keep the most common titles Mr. Miss Mrs. Master. Now we will be like applying the function on title. Sorry. So it will be like lambda is like for applying a function within a single line within dot apply. So it will be like if X in common titles, then it's X else other. So it will be like Mr. Miss else other. Mr. Miss message master else other. Again we are calculating value on this is that again. So you can also do binning according to age group. So 0 to 12 or any other age group. So binning is like you can in age group you can define the children's like either he's a child, teen, young adult, adult, senior. You can define the labels according to you, like whichever labels you want. So if a child is from 0 to 12, he's child. From 12 to 18 he's teen. 18 to 35 he's young adult. 35 to 60 he's adult. And 60 to 81 he's senior. Now we are using PD pandas cut function to just creating a new column of age group. That will be like every person. It will be like categorized as child, teen, young adult, anything. That's what this age group column does. For peer group, we are dividing it as like how much fare they gave, like very low, low, high, or very high. So yeah, we are using quantile cut here. There we are using cut and quantile cut. The difference is very simple. In cut we specify the range like 0 to 12. We specified in this range if any person age is there, he is a child. But in quantile cut, what we do is like we separate the data. We sort the data set first, then we like top 25 percentile will be among first level, next 25% will be 25 percentile in second level, and so on. This is how quantile cut works, like 20, up to 25 percentile in first level, 25 to 50 percentile in second level, 50 to 75 in third, and so on. Depends on how many levels you have. So yeah, see, you can see it like it's almost equal in all those pair groups. Final touch, it's like now we have some columns which we can drop and all. So you can see it here, like there is a name column. Obviously you don't require name of any person now. It's like generalize we are generalizing how many persons tried and all. We are extracting features. Ticket, no way you will use the ticket number of that person. Like sibling and spouse and parent and children. This can be useful, but we already created a column of family size, so it is no longer useful. So yeah, we are going to drop all these columns using df.drops or df.drop. In place equal to true implies that you do it in the actual data set. Categorical columns. So categorical columns, you can understand it as like if a particular column is having some categories assigned in it. For example, there is a column passenger class. There are categories in it, like either a passenger can be from passenger class 1 or passenger class 2 or passenger class 3. So all the passengers are divided among like 3 passenger classes, passenger class 1 or 2 or 3. So this is called categorical columns, like where the categories are decided for the entire data set in the particular column. So for sex, that is gender, either it is categorical as male or female. Embark, like which particular station you boarded from. Passenger class, I already told. Has cabin is like which cabin you are having. Either you are having a cabin or you are not having a cabin, 1 or 0. You are alone or you are not. Title, Mr. Miss, etc. Age group, which age group you belong to. Fare group, like you are like which fare group you belong to, low, high, medium, etc. For call in categorical columns, this is like okay, so we are assigning data type to that particular column. So all the categorical column we are assigning their data type as category dot h type. It can be int, float. There are many data types, so we are assigning it as category. Same for survived. Survived column is like 0 or 1, so we are assigning it as bool data type. So finally we are having like data frame dot info. It will be like giving you this. So yeah, see it. Passenger ID, it is like int data column, that is SR number. Survived is like bool column. Passenger class, we assigned it as category, sex also gender category. Age is like float. See, these are like predefined. Same for these all, we assigned categories. So this is the head of final data frame, which is passenger ID. These are survived columns. Passenger class, sex, age, fuel, embarked. 𝐻_Kevin is a column which we created. Family size also we created. Age room, title, age group, fear group. These all columns we created. So now let's move on to what we are here for, that is data visualization. Up to now we did data pre-processing. These were the steps which are necessary to pre-process the data. Without these, you cannot just move on to visualize the data. Else it will be like a real mess if you are going to visualize it. So yeah. So first, like at first you need to think what you can visualize in the data set. For example, you can just visualize like how many people survived and how many people didn't. So as you can see in this graph, this shows like count of how many people survived. True and false. True means they survived, false means they didn't. So these are survival counts. Like approximately 325 people survived, 550 don't. So how do we draw these graphs? Like that is the main visualization thing which we have to do. You don't have to remember any of these functions, nothing at all. You can just get them from internet, ChatGPT and everywhere. Only thing is that you need to understand how you are going to visualize. That's the main thing that's going to help you. So okay, let me explain you the code. So plot.figure, this is like fixed size, like figure size, how much figure size you want. Like 6 by 4, 6 inches by 4 inches. Length and width. You can just keep it as 10, 12 or any other, whichever size you want. sns.countplot. In 𝐶born library, we are having the function countplot. Countplot is like for plotting the bar plot. So yeah, bar plot. So this we are doing on the column survived, x equal to survived. That is on the column survived, which we created survived column. And data set, that is data equal to df. Df is like data frame. We are using the df.head, etc., etc. So that is data frame because we pd.read CSV, remember we kept it in df. So yeah, data equal to df. This is like title of the plot, which is survival count. This is like title. X label is like hello. X label is like how many, like the label on the x-axis. Y label is the label on the y-axis. Plot.show will show you the plot. So for pie chart, we are like using plot.py, but okay. In this chart, we are actually doing how much percentage of people, same as above, but we are just showing it using pie plot. So we are having like array or something. Survival count equal to data frame of survive.value counts. Value count just give you value count. Like for male, it will give you value count. For female, like value count. Sorry. Confused. Value count is like how many people survived and how many people didn't. So d of survived, like when survived equal to 0, it will give that value count. When survived equal to 1, it will give you that value count. So that is like survival count of 0 and survival count of 1. These are like labels, did not survive and survived. Colors you can specify or else it will automatically give you the color. This is the figure size. Plot.py, this is like function. This is like on which value you want to plot this pie chart. These are the labels which we specified above too. Also these are the colors. Auto percentage, auto PCT. This is like how you want to show it in this pie plot. For example, percentage 1.1f. It will be like after decimal, one digit will be shown. Percentage 1.11f. It will be like after decimal, 2 digits will be shown. If you don't specify, it will just go to up to 8 digits or like system specified digits, which don't look good when you plot the plot. Start angle equal to 90. Usually the plot pie plot start from 0 degree, like at the bottom. If you don't specify, it will start from 0. If you are going to specify, it will be like starting from that particular angle. This way it looks more readable. This is the title. Axis, it gives like equal axis as it is written for equal aspect ratio. It will show you the plot. Survival proportion. This is like gender distribution, like how many females and how many males were boarded on the ships. So we will create a gender counts, something like then def of sex dot value count. It will like sex is like male or female categorical data. So it will like df of like gender counts of male and counts of female. So labels is like gender count dot index, that is male and female. Color you can specify. Figure size. This is like data set or data gender count. Plot dot py. Labels equal to labels, that is those are the labels male and female. Colors. Auto percentage, but percentage like I already told you. Start angle is 140 here. This is like title is gender distribution, axis equal to equal. So that is like for showing equal axis show. So this is how it was actually like almost 65% of male were there on the ship and 35% of female were there on the ship. So now we are going to see survival by gender. So actually that's a big question, like how many males survived, how much percent of male, how much percent of female, or that's all. That's a big question. So this is yeah, actually see the plot. Survived, blue color is for false, this color is for maroon color is for true. So you can see it like only like 75 females died, whereas 225 females were like alive, and 400 almost 475 male died and almost 100 male only survived. This shows that women and children were given the priority first to escape rather than the male. So yeah, same way we are going to specify SNS.count plot for bar plot only. You have one major thing. So x equal to sex. It will just split your data into two parts. That is, sex column is like categorical data, male and female. So it is already splitting into female and male. But u equal to survive. What u does is like at any particular column, like for female, it will split that female column into other survived categories. Like survived have two categories, either he survived or he didn't. So what u does is it splits the female column into two more columns, that is survived and didn't survive. So u is like splitting a column which is already splitted. U does that. Yeah, kind of weird, but helps you visualize things more effectively. This is title of plot, X level, Y level. Plot.legend. Legend is like this box you see now, survive, true, false. This is legend. Then show, yeah. Don't expect much from me, like explaining code. All these code you can hit anywhere. Only thing is you have to get the idea of how to think of like what are plots to make, and this, that's a major thing. So this one plot is like survival by passenger class, like how many first class passengers survived, how many second, and how many third class passengers survived. Same way we are going to do here, like X will be passenger class here, U will be survived, like. So we are splitting it into splitting the data set into passenger class first. Then among passenger class we are creating two more categories, either he survived or didn't survive. This is title, survival by passenger class, X level, Y level. Then legend, survived, didn't survive. You can see the graph here. So it is very like easily visible that first class passengers were the first one to be survived. Second class passengers were little low than first class, but still yet they were survived. Third class passenger, when you will see the percentage, it was really unsafe for them to travel on the ship. So age distribution. So it will tell you like what was the age distribution of people which boarded on the ship. 0 to 10, 10 to 20. Like uh, bar chart, histogram, na. Same way we are winning the data. So in this first we specify the figure size, like this 8 by 4. SNS.histplot. Count plot is for bar chart. Histplot is for histogram. Pie plot is for SNS.py is for pie plot. Histplot, this is df or df of age, like whatever column you want to make it work upon, df of age. Wins equal to 30. So 30 wins means like you are splitting the age into 30 parts. If like 0 to 80 age is there, you are splitting it into 30 parts. That simply means column will be 0 to 2.5, 2.5 to 5, 2.5 to 7.5, and so on. If not 7.5, it will be like 0 to 2.66. That way it will be there. Like whatever when you can even have 10 bins. That way it will be like 0 to 8, 8 to 16. Let me show you. So yeah, see. So it shows like how many passengers survived in the age group of 0 to 8. Age group of 8 to 16, how many passengers survived. We are creating more wins so that we get more of accurate results. So yeah, in 0 to 3 approximately we get like 25 people survived. Young people survived most, but you don't know how many people died. Title, X level, Y level, you already know. So now we are like survival by age group. Like age group, how many people survived? Like how many childs survived, how many teens survived, adult, senior. We have to see that. So as you can see, like half of the children died, more than half of the teens died. For adults also, same case. For seniors also, many people died. So what we are doing here, I know we have already created a column for age group, but yeah, I am creating it again. I might have forgotten it at that point of time. So yeah, so what I am doing, df of age group equal to df of age dot apply age group. So dot apply is like applying any function on the particular column. So this is my function age group. When you will pass age in it, if age is less than 13, it will return child, else it will return teen, else adult, else senior. So age group will be categorized as child, teen, adult, and senior. So you are creating a count plot here. Count plot is like X is like age group, so it's like categorical data as I have already explained, child, teen, adult, senior. So it will be divided in 4 parts, child, teen, adult, senior. Now you are that particular column, like child, you are splitting it into survived, didn't survive. Same for adult, teen, senior. You are doing same for every column. So you are splitting the column which is already splitted. Data, which is df, data frame. Order is like which order you want. Like this is attribute which you can see use for count plot. There are many other attributes which means just go and Google them. The more you practice, the more you learn. That's the simple thing. Order is like child, teen, adult, senior. Like this is order what we want. Title, X level, Y level. Legend is like I already told you, this is the legend. Plot dot show. This will show you the plot. So now we are creating another another graph. We are visualizing it like average age of a passenger class. Like what was the average age of first class, second class, third class? That simply means like out of those people which boarded on the ship, what was the average age of them? So for first class it was like around 37, second class it was around 30, third class it was around 26. That simply shows that younger people were more of like socio-economic weaker than the older people. So people who were traveling in first class were a bit older than those traveling in other class. So this is what you say. Array or something, df dot group by passenger class. It will just group a passenger class No, no, no. DF dot group passenger class of age. So what it will do? It will group your it will group your passenger class. It will group your age according to passenger class. Yeah, that's what it means. So, for example, for passenger class first, it will just take all the passengers of that class, their age column. It will just take off all the passenger of first class. Then it will calculate mean of that particular column. That means all the passenger of first class, what was their mean? Same for second, same for third. What was their mean of their age? Plot dot plot. This way, plot means plot dot plot. We are going to plot the line plot. Figure size average. This is average age by class. That is dot index, like passenger class first, second, third. This is index. Their values, like these values, whichever values they hold. Marker equal to O, that specifies what color, how texture is going to be. Line style equal to line, this texture. Color equal to purple. There are many other attributes for every plot. You can just see it. You can have it. The more you search, the less it gets. So this is title, like average age of passenger class. X level is like passenger class. Y level is average age. Plot dot x text. X text is like X level, like 1, 2, 3, like X text. Tech Y like passenger class. It will tell you grade, and it will show you the plot. This is line plot. The line plot you plot using plot dot plot. Survival with family size, like it tells you, like out of those people traveling alone and those people, like what was the family size and how much percentage of family size survived. So this is figure size. Count plot is like your like family size column you already have, so we are taking family size as x. U equal to survive, data equal to df. Survival by family size, that is title. X level is family size, count is y level. Legend, that is survived years. Show, it will show you the plot. So now it's like if you are traveling alone, if you are not traveling alone, what was the percentage of survival when you are traveling alone and when you are not traveling alone. So you can see it here. Blue is for not survived. So you can see it here, like more people, like 1/3 of people survived when they were traveling alone. Whereas 2/3 of them died. For when they were not traveling alone, when they were traveling with family, spouse, children, or any other way, half of them, more than half of them survived. So it shows like traveling alone is not always so useful. This is figure size. Count is like S alone. We already have S alone column. U equal to survive. That's like dividing the S alone columns among survived. That is they survived or not. Title X level, Y level. That's like you can just give it. That's not always necessary. Plot dot x text 0,1, not alone. Legend is like this, title equal to survived. Survival by title, like Mr. How many Mr. survived, how many Mrs. survived, how many Master, and what all, like how the people survived according to their title. We have to look after every aspect before we come to any conclusion, like why more females survived than male, because females were given priority at that particular point of time. Why more of Mr. title died, because men are not given enough priority. Message, see, more of Mrs. title survived because they already have their children, might be having their children, or might be pregnant, or there can be any other cases. Same for Miss Master, that is children and others. They are how they survive. So same way SNH count plot, x equal to title. We are splitting data set according to their title. Then those title we are splitting according to the survived. They survived or not. So yeah, we give x level, y level, legend, and all. Survival by fair when, like how much fair you kept and what percentage of survival you had. Like if you gave more fair, how much chances you had to survive. So if you give very high fair, then you are most probable to survive. See, these are the columns. If you give high figure, still you are probable. Medium, still. But low, very risky. Like very less people who gave low fear did actually survive. So yeah, we are creating a new column if you win. It's like quantile cut, low, medium, high, very high. Figure size you already know. X equal to Fairwind, it's splitting the data set according to Fairwind, low, medium, high, very high. Then it's splitting any particular column according to whether they survived or not, 0 or 1. Title, X level, Y level, legend, and all. You already know that. Survival by port of embarkation. So it's like from which port you boarded, that port actually helped you to survive somehow. So you can see it like most of the people boarded from S port, a few boarded from Q, and few boarded from C. But yes, as you can see, like almost if you are going percentage wise and C port is like having the highest percentage of survival rate compared to others, but still you can just keep it, see it like if any of that data match. This is figure size, X equal to embarked. They are splitting data set according to embarked column. These are like survived or didn't survive, title and X level and all. You know, box plot as already Shashank explained to you. It's like telling you if uh, like splitting the data. You can understand it. So let's analyze this box plot. So it's like for passenger class versus age. Do this like which passenger was traveling, which what was the age of the particular passenger class, something like that you can say. So you can see like passenger class one. This is the line which shows median. This is the line which shows median. This is the uh, lowest age in first class. This dot you see. This is the highest age in first class. This is the median age of first class. This is like 25 percentile of the data. So what you understand by 25 percentile of data? You might go over about that. So it's like if you are having 100 persons in a data, if you are having 100 person in first class and their age, and out of those 50 people age is between 30 to 50, those will be here. Remaining will be like here, like these whiskers you can see. Remaining will be here. This dot which you can see, it is like an outlier to which you can understand is like there is a specific formula to calculate outlier, that is like 1.5 plus IQ, 1.5 into IQR, median plus 1.5 into IQR. Let's not go deep into that, but you can understand these are the outlier. Like 80 age is like too much, so no people actually traveled of that age. Most of the people were between 30 to 50, 50% of people. Remaining were from 0 to 70. For second class passenger, most of the people were from 20 to 35. First class, most of the people were between 20 to 30. Yeah, 29 to 28 to 29, something 27 to 29. Almost 25% of people were there in that particular age group. These all are the outliers. Don't worry about them right now. There is a formula which you will read them. Sure. So this is figure size. For box plot, we use the function dot box plot. This is how we are splitting the data set x equal to passenger class. So we are splitting data set according to passenger class. Box plot requires two column, passenger class and age. Like y equal to age, x equal to passenger class, y equal to age. Data set equal to data frame, which imported data. This is title, this is x level, this is y level. Yeah, so we showed it. So is there any doubt or something? You can just ask it. Hello? Am I audible?
Yeah, you're audible.
So I don't think there are any doubts from the students. You continue, Shashank.
Okay, so let me continue. Just a second. Okay. Yeah, I hope my screen is visible. So let's go on.
Yeah, yeah, there.
So, okay, this is a quick quiz. Which of the following is not the purpose of exploratory data analysis? A, to build and deploy a final machine learning model, to understand data distributions, to detect outliers, to visualize relationships in data. Okay, so as you guys guessed it is A, to build and deploy final machine learning model. It is not what we're trying to do. We are trying to understand data distributions to detect outliers. We want to understand the different relationships, and then yeah. So EDA is about exploring. It's not about directly going and building the final model. Okay. So as I just now told, EDA is investigation. So it's if you guys want a reference, it's like your Sherlock Holmes, and you don't want to make an arrest. That is, build the model until you walked into the crime scene data set, which is the data set. So you can ask what suspicions, what are common, what's odd, what is predictable, and then there are this EDA, exploratory data analysis, was actually coined by John Tuckey in the 1970s, and it is essentially the most crucial step. So around there's a statistic that around 80% of data science effort goes into exploratory data analysis and data cleaning. So it is a very important step. So these are the different learning resources you guys can use. There's Coursera. You guys can get certificates on data science or machine learning, and courses from Stanford, Deep Learning.ai. There are various YouTube channels you can use to refer. Yeah, there are Geeks for Geeks. And you can also go on Kaggle or any other website and find data sets to learn, and also participate in competitions. So you guys just now use Python, Pandas, NumPy, and all of them. You guys can expand it on as well. Also, when it comes to graphs, you guys can explore other ones also, like heat map, which you guys can use to visualize correlations between different features. You guys can use tree maps. You guys can use stack bar plots. You can try all these. So essentially, the best way to learn is to actually practice it and try and build your own models. So this is the roadmap from the last session. So we just now completed phase 2. So from now, you guys can start machine learning. You guys can see what is going on. And then there is phase 4, it's the deep learning. So we can cover this when we start college. Okay. So essentially, what did we learn? So EDA is the first step for any model. It saves times, or it prevents errors, and you can't proceed without EDA. So to wrap up, we saw it's essential. We learned about descriptors, statistics, the types of charts, how you build relations. We just now practiced on the Titanic data set. You guys can apply the same thing to different other data sets of your choice. And there are, as is now told, there are different data sets you guys can work on. The retail sales data, YouTube, IPL, and others as well. And you guys can try and answer these questions. Okay, if you guys have any questions, you guys can ask. Okay. So if you guys don't have any questions, I think we can wrap it up. You guys can connect with, these are our socials. Okay. And you guys can fill the feedback form if you want. So thank you.
Thank
Jatin, do you have anything to add?
And that's all. Thank you guys for attending this session.
Thank you guys. You guys can